At first glance, the German pilots were unimpressed. When Luftwaffe crews encountered the new British fighter in late 1940, they reacted as seasoned aviators always had, by judging it in the air. What they saw looked wrong. The aircraft was huge by fighter standards, its fuselage thick and swollen compared to the sleek Messerschmitt Bf 109 it was supposed to challenge. Twin engines gave it a muscular presence, but the overall silhouette suggested something slow, almost agricultural. German intelligence reports from early encounters labeled it heavy, sluggish in turns, and lacking the elegance of single-engine fighters. Some pilots mocked it openly, convinced they could outmaneuver this British newcomer with ease. That confidence survived right up until the first burst of fire. What the German pilots could not see from the outside was what lay beneath the aircraft's nose. Clustered tightly in the belly were 4 Hispano Mk2 cannons, each 20 mm in caliber, mounted side by side in a compact block. Unlike wing-mounted guns that relied on convergence, these cannons fired almost perfectly parallel. At 250 meters, their shells struck within a space barely a meter wide. When the pilot pulled the trigger, he was not spraying bullets. He was projecting a solid wall of explosive force. Each Hispano shell weighed around 130 grams and left the barrel at nearly 880 meters per second. Every round carried a high-explosive incendiary charge designed to detonate on impact. Multiply that by 4 cannons firing roughly 600 rounds per minute, and the effect was devastating. In a typical 2-second burst, the aircraft hurled close to 80 explosive shells into the space ahead, enough to tear through aluminum airframes, sever control systems, ignite fuel, or simply rip an aircraft apart. German bomber crews learned this arithmetic brutally fast. Aircraft like the Dornier Do-17 could survive dozens of rifle-caliber hits and limp home with holes patched over later. They could not survive 4 20mm cannons firing together. Early victories were not dogfights in any traditional sense. They were brief, violent encounters. Bomber crews reported seeing the twin-engine fighter approach from below or behind, appearing too slow to pose a threat. Then their aircraft simply ceased to exist. Wings folded as spars were cut through. Fuselages snapped. Engine nacelles erupted into fire that consumed entire wings in seconds. One Luftwaffe pilot who survived an attack over the English Channel in March 1941 described the moment in his debriefing. Flying wingman in a returning formation, he noticed the British fighter climbing beneath them. He assumed there was time to evade. The British aircraft opened fire from what seemed an absurd range, over 300 meters, and his commander's aircraft ahead of him didn't burn or trail smoke. It exploded, as if struck by anti-aircraft fire. The entire engagement lasted less than 4 seconds. That was the moment the equation changed. This aircraft did not need agility. It did not need prolonged maneuvering. Its targets vanished in a single firing pass. And that was no accident. The design was born out of desperation. In 1940, Britain faced overlapping crises. Bomber Command needed long-range escorts. Coastal Command required aircraft capable of hunting U-boats far out over the Atlantic. Fighter Command needed night fighters able to carry bulky new radar systems. Designing a new aircraft from scratch would take years, time Britain simply did not have. Bristol's chief designer, Leslie Frise, chose speed over elegance. He built a fighter from parts that already existed. Wings from the Beaufort torpedo bomber. A tail assembly from the Blenheim. Hercules radial engines already in mass production. Even the landing gear was adapted rather than reinvented. It was not refined engineering, it was industrial pragmatism. The results were astonishing. Design began in October 1939. The prototype flew on July 17, 1940, just 9 months later. The wings, built to carry a 900-kilogram torpedo, easily absorbed the recoil of heavy cannon fire. The spacious fuselage housed radar equipment, a second crewman, and massive fuel tanks that gave the aircraft extraordinary range. Almost by accident, Bristol had created a fighter that was large, durable, long-legged, and lethal. By September 1940, No. 25 Squadron was operational. Within weeks, these aircraft were flying combat missions over Britain at night, hunting bombers that had once operated with near impunity. Central to this success was the decision to mount 4 Hispano cannons in the belly rather than scatter weapons across the wings. Without convergence issues, every shell struck the same area at any range. 4 explosions arrived almost simultaneously, each one compounding the damage of the last, tearing bombers apart from the inside out. The Hispano Mk2 itself was a formidable weapon, French in origin, refined in Britain, firing high-explosive incendiary shells capable of shredding aircraft structures in fractions of a second. In a single burst, dozens of shells struck home before a target's crew could even react. And this was only the beginning. Because once German pilots understood what this aircraft could do, they began changing how they flew. And the air war over Europe was about to enter a far more dangerous phase. To put this in perspective, in just 2 seconds, the amount of explosive fired by this aircraft was more than what many light bombers dropped in a full bombing run. This wasn't a normal fighter. It was flying artillery. Alongside its cannons, the aircraft carried 6 additional machine guns. 4.303 Browning guns were mounted in the wings, and on some variants, 2 more were fitted in the outer section of the right wing. These machine guns were not meant to destroy aircraft on their own. Their real purpose was psychological. The tracer rounds showed the pilot exactly where his fire was landing, allowing him to correct his aim instantly. At the same time, the bright streaks of incoming fire forced enemy gunners to duck on instinct, suppressing return fire during the few critical seconds when the fighter closed in to lethal cannon range. Luftwaffe bomber crews quickly learned to recognize this aircraft's attack pattern. First came the tracer rounds, slicing bright lines through the darkness. Then came the cannons. And by that point, it was already too late. German military intelligence took pride in careful aircraft analysis. When wreckage from one of these fighters was recovered near Dover in November 1940, analysts did what they always did. They measured, weighed, and calculated. The wingspan measured 17.6 meters, noticeably larger than the Bf-110's 16.3 meters. The fuselage was long, bulky, and cylindrical, measuring 12.7 meters. Most revealing was the weight. Around 6,800 kilograms empty, and nearly 9,500 kilograms fully loaded for combat. The conclusion seemed obvious. An aircraft this heavy, with this much drag, could not possibly be maneuverable. The report circulated through Luftwaffe units in early 1941, labeling the aircraft as a heavy fighter, with strong emphasis on the word heavy. Yes, it noted the twin Hercules engines producing roughly 1,400 horsepower each, but claimed that this power was simply absorbed by the aircraft's size and weight. Maximum speed was estimated at around 515 kilometers per hour, slower than the Bf-110. What this assessment completely missed was one critical fact. Maneuverability and combat effectiveness are not the same thing. German intelligence focused on turning radius, roll rate, and acceleration. These mattered in daylight dogfights between single-engine fighters. But no one seemed to consider that night combat followed entirely different rules. This aircraft didn't need to outturn a bomber. It needed to approach within 300 meters, unseen. It needed to hold a stable firing position for 2 seconds. And it needed to survive long enough to escape. Because of this flawed analysis, bomber crews were briefed that if intercepted, they should attempt tight turns. The British fighter, they were told, wouldn't be able to follow. Several Ju-88 crews tried exactly that in early 1941, and paid with their lives. The fighter didn't need to follow a violent turn. The pilot simply waited. When the bomber finished maneuvering and stabilized, the fighter fired directly into its predictable flight path. The extra second spent turning only made the bomber an easier target. A more accurate analysis would have highlighted the aircraft's true advantages. Its large size allowed it to carry the AIMK-4 airborne radar, a heavy and bulky system weighing around 90 kilograms, operated by a dedicated radar operator. Smaller fighters simply couldn't carry this equipment. Inside the spacious fuselage, the radar operator could work efficiently, guiding the pilot through total darkness. The Germans were aware of airborne radar. Their own Liechtenstein system was under development. But they failed to connect the aircraft's size with its ability to carry advanced electronics. The aircraft's strength was another overlooked factor. Built using reinforced bomber-grade wings, it could dive at extremely high speeds without structural failure. Luftwaffe crews reported terrifying attacks with a fighter dove from above, fired a short burst, and vanished before defensive gunners could react. German intelligence dismissed these reports as exaggerations caused by combat stress. By mid-1941, bomber loss reports told a different story. Aircraft were vanishing over Britain. No radio calls. No distress signals. Just empty gaps in formations. When wreckage was recovered, the damage showed catastrophic structural failure, consistent with heavy cannon fire. Still, the official assessment remained unchanged. Heavy, slow, dangerous only if mishandled. The truth revealed itself night after night over Britain. During the Blitz, bomber streams crossed the Channel under cover of darkness. British night defenses had once been ineffective. Searchlights scanned empty skies. Anti-aircraft guns fired blindly. Fighters hunted shadows. Only about 2% of bombers ever encountered opposition. That changed completely when this fighter was paired with airborne radar. Ground radar stations guided it close. Then the onboard radar operator took over, calling out bearings and range. The pilot crept in below and behind the bomber, staying outside the gunner's view. At around 300 meters, visual contact was made. A dark shape against darker sky. 2 seconds of fire. And the bomber didn't burn. It disintegrated. Between November 1940 and May 1941, these fighters claimed over 100 confirmed kills, all at night. Each one represented an interception that would have been impossible just months earlier. The psychological effect on German crews was devastating. Flying through darkness, knowing something unseen was hunting you, knowing your first warning might be cannon shells ripping through your aircraft. Some crews requested transfers to daylight operations just to escape the terror. The aircraft didn't need to destroy every bomber. It only needed to make every crew fear the night sky. By early 1942, its effectiveness against bombers was undeniable. But now, British planners saw another use for its brutal firepower: attacking ships. 3 major German warships sat in Brest Harbor, daring Britain to strike. Repeated bombing had failed. Losses were heavy. Then Hitler made a reckless decision. He ordered the ships to sail straight through the English Channel, in daylight. What followed would become known as the Channel Dash. And it would push this aircraft into a role even more dangerous, more violent, and more unforgiving than night fighting in the skies. Because the next phase of its story wouldn't be fought in darkness. It would be fought at wave-top height, against steel, fire, and the full fury of naval defenses. They began attacking at wave-top height, flying literally just meters above the sea. By staying this low, they slipped under enemy radar and created impossible firing angles for anti-aircraft gunners. At such extreme low altitude, the aircraft's size and weight became an advantage. While lighter fighters bounced violently in the turbulent air above the waves, this aircraft remained stable, steady, and deadly accurate. A typical attack unfolded like controlled violence. The fighters approached in a line-astern formation, each aircraft separated by a few seconds. The lead pilot lined up on a merchant ship's waterline and opened fire from around 600 meters. 4 cannons tore into the ship's hull, punching holes through steel plating. The 20mm shells didn't sink ships outright. They weren't torpedoes. What they did was often worse. They shredded superstructures, destroyed bridge equipment, killed crews manning anti-aircraft guns, ignited ammunition stores, and ruptured fuel lines. By the time the second and third aircraft attacked, defensive fire had already collapsed. Gunners were dead, wounded, or hiding from a storm of exploding shells. That was when the torpedo bombers following behind struck, launching with far less resistance. The results were devastating. Between June and November 1942, these squadrons operating from Malta helped sink or damage over 90 Axis vessels, totaling roughly 300,000 tons. Compared to the Atlantic War, the numbers seemed smaller. German U-boats sank far more ships, but they operated hundreds of submarines across an entire ocean. In the Mediterranean, there were never more than about 60 of these aircraft operational at one time. Yet their tonnage destroyed per aircraft exceeded that of the U-boats. The strategic impact was undeniable. By November 1942, Rommel's advance into Egypt stalled. Fuel shipments stopped arriving. Ammunition convoys burned at sea. Italian merchant captains began refusing to sail without massive air cover. Cover the Axis simply couldn't provide. Captured German documents later revealed the scale of the disaster. By October 1942, less than 30% of supplies shipped from Italy reached North Africa. The rest lay at the bottom of the Mediterranean. Individual combat reports sounded routine. Attacked 3 merchants off Lampedusa. Left 2 burning. But multiplied across dozens of crews, the effect was catastrophic. While Axis shipping was being torn apart in the Mediterranean, another theater halfway around the world demanded the same brutal capabilities. The Pacific presented even harsher challenges. Distances were vast. Missions could exceed 1,600 kilometers round trip. Tropical heat and humidity destroyed engines and electronics. Japanese Zero fighters were deadly in turning combat. When the Royal Australian Air Force received its first of these aircraft in late 1942, they were heavily modified for Pacific conditions. Engines were improved for cooling. Radios were protected against moisture. Extra fuel tanks extended endurance beyond 6 hours. A new variant followed in early 1943, armed not only with cannons and machine guns, but also rockets and torpedoes. Few aircraft in the world carried that level of firepower in a single airframe. Operations against Japanese shipping began in mid-1943. Convoys supplying New Guinea and nearby islands tried to move at night. The response was simple: low-level dawn and dusk patrols, striking when Japanese fighters were least effective. During the Battle of the Bismarck Sea in March 1943, this aircraft helped annihilate an entire Japanese convoy. 8 transports and 4 destroyers were sunk. Nearly 7,000 troops were lost. Cannon fire ripped through wooden superstructures, igniting fuel and ammunition in seconds. By late 1943 and into 1944, operations expanded into Burma and the Bay of Bengal. Missions stretched pilots and machines to their limits. Some crews returned with barely enough fuel to land. Japanese commanders adapted quickly, but grimly. Captured orders instructed convoys to scatter immediately if attacked by twin-engine fighters. Ships were even told to run themselves aground if damaged, rather than remain at sea where another attack would finish them. By the end of the war, German intelligence assessments had completely reversed. Gone were the early labels of heavy and unmaneuverable. The final reports acknowledged what crews had known for years. Once this aircraft achieved firing position, survival was unlikely. Evasive maneuvers didn't work. Turning didn't help. Speed offered no escape. The only real defense was not being found at all. Statistics confirmed it. Bombers damaged by single-engine fighters often limped home. Bombers hit by this aircraft almost never did. The 4-cannon burst left nothing flyable behind. Fear became as powerful as firepower. Crews across Europe and the Pacific learned to dread the silhouette of a twin-engine fighter. The sound of Hercules engines at low level meant destruction was seconds away. By war's end, nearly 5,900 aircraft had been built. Over 5,700 enemy aircraft destroyed. More than 600 ships sunk or crippled, totaling over 1 million tons. Losses were heavy, but the exchange ratio was brutal. For every aircraft lost, nearly 7 enemy aircraft or multiple ships were destroyed. Even Germany's most successful pilots admitted the truth after the war. This aircraft wasn't feared because it was agile. It was feared because its attacks were short, sudden, and final. The Germans had called it heavy and slow, as if those were flaws. They were simply the traits of an aircraft built for one purpose: to carry weapons, fuel, and systems smaller fighters never could. To strike once, and to end the fight immediately. It didn't need to dogfight. It needed to kill. and when those four cannons fired together, maneuverability stopped mattering at all.